Okay, let's look at a question based on the graph that you see here. So if you look at this graph, you can see on the x-axis here we have Q for quantity produced, and on the y-axis we have costs. And there are three types of costs being graphed. Each of them is a per unit type of graph. So we have the average total costs, which is the total costs per unit. We have the average variable costs, which is the variable costs per unit. And then we have the marginal costs, which is the change in the total costs per unit. So the question is, where would we measure the average fixed costs at Q1? So we haven't graphed here the average fixed costs. Okay, but we can find it from the graph, and the question is asking you to work it out from the graph at this particular point here. Okay, so what we know is that the average total cost is made up of average variable costs plus the average fixed costs. Okay, so the gap between these two lines here, the vertical gap between these two lines, this here will equal to the average fixed costs. Okay, that's what this answer gives you there, the vertical distance. So to calculate it, you go across here, you dot across here to the y-axis, mark off where the costs are at Q1 on the average total costs, and mark off where the costs are for Q1 on the average variable costs, and you would subtract the smaller from the bigger, and you'd calculate this gap here. Okay, they're supposed to look like the same size here. I just have to go straight across there. Okay, another question. Where does the marginal cost, remember that is the cost for the increase in the total cost for each additional unit produced. Where does the marginal cost curve, so that's a graph, intersect the average variable cost and the average total cost curves? Okay, and that's easy to identify the answer to that. It's just going to be here it intersects with the average variable costs, and here it intersects with the average total costs. But the more interesting thing to answer is this, why is that? Okay, and there's an interesting to note about where the marginal costs intersects with each of these curves. So we see it intersects with the average variable costs at its minimum. So we can see the average variable cost is reducing along for each additional unit at the start, but it reaches a minimum here, and then it starts to increase after that. So we can see it increasing after that. Okay. Similarly with the average total costs, this is reducing for a little bit longer, because remember the average total costs includes the fixed costs per unit. And as the units go up, that will decrease because the fixed costs are fixed, but the number of units is increasing. So the average total costs reaches a minimum here at a slightly larger quantity, and then it starts to increase. And the interesting thing is that the marginal cost, which is the cost for each additional unit, intersects at those minimums. Okay, so that's what's mentioned here, at their minimum points. Yeah, and the explanation as to why this makes sense is that as long as the marginal costs is below each of these curves, it will be pulling the average costs down. Okay, so the additional cost for each unit here is less than the average variable cost. So if the additional cost per unit is a lower number than the current average, then the new average will be slightly lower than it was before. Okay? Because we're adding a smaller number and then dividing by the number of units, so that will, which is increased by 1, so that will make the average a little bit less. Okay? But if the marginal cost is bigger than the average variable cost, as it is here, then the cost of this extra unit will be higher than the average cost of all the units preceding it, and it will start to pull the average variable costs higher. Okay? Similarly here, where the marginal costs, that is the cost per unit for each additional unit, is higher than the average total costs, that means that this unit here, this new unit up here, will be pulling the average total costs higher. So that is a very interesting thing, that the marginal cost will always intersect these curves at their minimum point. So the graph below shows us some features of the average costs and how they relate to the marginal cost graphs. And as we discussed in the last slide, there are some features here that will always be true. One of those being that the marginal cost graph will always cut the average total cost at its minimum point, and it will always cut the average variable cost at its minimum point. Okay? The relationship between the average total cost and the average variable cost will be that the total cost will be greater than the variable costs by amount equal to the average fixed costs. Okay, so this mark here, the average fixed costs, the gap between those two graphs will always equal to the size of this average fixed costs down here at any point. You can note that the average fixed costs is always decreasing. Okay, and that is because you have a fixed number which is getting divided by a bigger and bigger number as the units increase. Okay, that means that the average variable cost and the average total cost will be getting closer and closer together. Okay, so here we can see the relationship between the marginal cost and the average total cost. Okay, we noted that it will intersect at the minimum of the average total cost. The shape of the marginal cost graph, which is this one here in red, will typically be decreasing at the start. And the reason we might typically see that is because we will be getting increasing efficiency of labor specialization. So instead of having one person doing everything, we can break up tasks so that people can specialize on one part of the production. This will increase the marginal returns. So we'll have increasing marginal returns, meaning for each additional, let's say, person added in this part of the graph, the change in total output per unit produced will be more, yeah, and so the marginal cost will be less. So the cost per unit produced will be less for each additional unit produced at this early stage in the graph. Okay. Now later on in the graph, we will see that the marginal costs will start increasing. Okay, and the reason for that is that we have run into the law of diminishing returns. As we start to, for example, add more and more and more people on a production line, it might get overcrowded and we have less and less efficiency for each additional person that we add. Okay, so that's quite a typical shape to see for the marginal cost graph. And here we again see the explanation as to why the marginal cost graph cuts the total average costs at its minimum. Yeah, and the reason is that if the marginal cost is below the average total costs, then each additional unit will be lowering the average total costs. So at this point here, this value is below this value, so we would expect the new average total cost to be lower because we're adding in a smaller number than the current average. But when they're equal, we would expect the additional unit to have no change on the average. But when the marginal cost, the cost for each additional unit, is higher, up here it's higher than the current average cost, which is down there at that particular quantity, that means that each additional unit is pulling the average total costs higher. So we would expect this to be increasing from this point on because the marginal costs is higher. Okay? So the pattern that we would tend to see is that at the start of the marginal cost curve, we have increasing specialization, which leads to lower marginal costs. So each additional unit is costing less per unit, right? Later on, we will have increasing marginal costs, where each additional unit will cost more than the previous unit. So here each additional unit is costing less, and after this minimum here, each additional unit will be costing more per unit, okay? So remember that the marginal cost is a cost of one additional unit, right? So the change in the total costs for that additional unit, okay? Once the value of the marginal costs passes through this curve, the average total cost curve, then each additional unit produced will start to push this curve higher, okay? Meaning that the average total costs will start to go up, okay? Similarly, we can mention that when it passes through the average variable costs, it will start to push the average variable costs up. So you can think of the effect of the marginal cost as being like a magnet. When it's below the total average costs, it will be pulling these values downwards. Yeah? So later on, at a higher quantity produced, you get a lower average cost, and it's still below here, so it will still be pulling this downwards. But when the marginal cost, that is the cost for each additional unit, is higher than the average total costs, it will be pulling the average total costs upwards. Okay, so next we're going to start thinking about how we analyze the costs in the long run. And we need to think to ourselves, what do we mean by the long run? What time period would be considered a long run time period, and what time period would be considered a short run time period? Okay, so the long run is defined as being the time where a firm or a company is perfectly flexible in its choice of all of its inputs to the production process. So in other words, the firm is not stuck with some fixed resources. So we won't be considering these fixed costs in our long run analysis. So a firm could decide to build a new production facility or modify an existing production facility when we're working out its long run costs.